So section 10.3 is on chords. We're going to talk about all the properties of chords and arcs in a circle. So right off the bat, if you have two chords in the same circle and the chords are congruent, then the arcs are congruent, and it works both ways. If chord BD is congruent to chord DC, then arc BD is going to be congruent to arc DC. I like to say equal chords strike equal arcs. In this picture, if we have the two arcs XY and YZ being congruent, then we know that YC, that ray YC, bisects the arc XYZ, or XZ in this case. Alright. If we have a one chord in a circle perpendicular to another chord in the circle, then we know that one of them has to be a diameter. Can't be any other way that you can have perpendicular chords. So if one is a perpendicular bisector, then it's got to be a diameter. In this case, chord DC is perpendicular to chord BY. So we know that one of them has to be perpendicular, or a diameter. In this one, if a diameter is perpendicular to a chord, then that diameter bisects the chord and the arc. Right? If the diameter is perpendicular to the chord, then the diameter bisects the chord and the arc. If you have two chords and they're the same distance from the center of the circle, and of course distance is perpendicular distance, so two chords that are the same distance from the center of the circle have to be congruent. If the two chords are equidistant from the center of the circle, they have to be congruent. That's a lot.